For this last section in our course 16.3, we'll wrap up a number of important concepts. First of all, we've integrated a rich variety of aspects from the ROS ecosystem. We've modeled many things through Gazebo and RViz. We've done perception from various sensors, done navigation through the mobile base, and manipulation through the robot manipulators. In communication, we've used all forms of ROS communication, including the parameter server, publish subscribe nodes, services, and action servers. In terms of planning, we've done perceptual processing to find object, arm motion plans to manipulate object, and mobile navigation to reach locations. We have simulation of robots, we have simulation of sensors, we have the models of the robots themselves, and we have the visualization of the data. We're using various hardware, including the dual-arm robot, the mobile platform, the Kinect sensor, and of course we're doing the navigation with respect to a map using sensor-based localization and global local motion planning, and actually driving the vehicle and controlling the wheels. Now, it's important to say that the things we have presented up to this point are still minimalist examples. That means they're still very simple because they're used for illustration. And so there's still a number of weaknesses. In the perceptual system, we're only recognizing one very simple object with a known height. And so this could be definitely expanded with many more advanced techniques and ways of recognizing objects in 3D space. For the object manipulation query service, we're also have been looking at the example of a single object, though the Coke can also be recognized, and we're just looking at the electric fingers, though you can use the vacuum gripper kind as well. But we could expand this to include a large number of hands or end effectors and different kinds of objects to grasp, so the database can grow in size significantly. The navigation plans that we executed, you had poor driving precision. They were not the best configured routes and not the fastest ones either, but so all of this can be improved. And at the end, as you saw, there was no error detection and correction. So there was no ability to identify this failure or recovery techniques. This is a huge area in robotics, all the more when you move to the unstructured environment and the human-robot interaction. And actually, this is one of my focuses and my personal research. And so if you want to learn more about how to do some of these things, please visit my website. But regardless of the weaknesses, there's many key lessons that we have learned. We've seen examples that show us the potential of ROS to really simplify the building of large and complex systems. Every lesson we have been added one more layer of complexity in a modular way. And in doing so, we're simplifying significantly how to build this complex system. We've seen how the use of ROS packages, nodes, and messages have promoted the use of promoted modularization, keeping things independent, the ability to reuse things over and over in slightly different contexts, allowing things to collaborate with one another, extending it, and testing it. So ROS really fulfills its vision of being a robot middleware that facilitates complexity. We believe ROS is really a great foundation to build highly complex robotic systems for the future. There's a reason why ROS has been massively adopted throughout the world very quickly, because it has really eased the way in which we program complex robotic systems. And while we say that, it doesn't mean that ROS is still an easy thing to learn, or it doesn't mean that designing a complex system will be easy either. But it has reduced the complexity of coding large and complex systems very, very significantly. So we're coming to an end of this course, and I hope that you have been able to enjoy the process of experiencing a systematic increase in your knowledge and skill with regards to ROS, and that you can take the principles that you learned here and then adapt them to whatever situation or robot you're working with, whether it's a UAV, a mobile platform, an underwater robot, a space robot, or anything else. Really, ROS doesn't limit us in any shape, way, or form, and what we can code. It's simply the skeleton. And it gives us tools that we can use then to create our own robotic systems. I wish you all the best, that this is just a starting point in your robotics career. There's so much ahead in robotics in decades to come, with so much promise of development. And I hope, it's my sincere hope, that the robots that we make can be of great service to humanity and building better societies and helping us to achieve higher purposes in our life. Thank you very much. And next week we will look at a final project and close up with some details in the class. Take care.